So this question asks us for the rate of change at one specific moment in time. We've dealt with rates of change in the past where you have an interval in which you're working with, and we know that that's just our slope. And our slope is just going to be found by y2 minus y1 over x2 minus x1. The problem that we run into in this problem is that we're just given one x value. So we have the 0.5 and then the y value associated with that, which is just the square root of 2. So we only have one of these points. So we have an x value and a y value. So we have to have a second point. So we can either use the difference quotient or the alternate form in order to find out what the instantaneous rate of change is at this point using limits to connect them. So if we use the alternate form of the derivative, okay, so the alternate form of the derivative tells us it would be the limit as x approaches that x value of f of x minus f of c, so minus f of 5, over x minus 5. So this is the structure of what the alternate form would look like. And we know what f of x is because f of x was defined in our problem. We know what f of 5 is because we just evaluated that. When we plugged 5 into our equation, f of 5 ends up being the square root of 2. And then the rest of it falls into the equation that we have here. So my limit as x approaches 5 of the square root of x minus 3 minus the square root of 2 over x minus 5. So now we turn this into a limit problem. So by doing this limit problem, we always try direct substitution. If you try direct substitution, it's unfortunately in the form of 0 over 0. So we can't actually analyze that by direct substitution. So we're going to do something else. So a limit that looks like this that we want to evaluate, you have to remember that you're multiplying this by its conjugate. So the square root of x minus 3 plus the square root of 2. And we're going to do that both the numerator and the denominator because that's equivalent to multiplying by 1, so we don't actually change the value of anything. So now when we do that, we're going to rework what we have. So we're going to multiply these out. When you multiply by the conjugate, just multiply the parts of the conjugate. So we'll end up getting just x minus 3 and then minus 2 over, and then the denominator, kind of leave it that way. Don't multiply that out. It wasn't the conjugate. It'll just make your life easier as you go through. Okay, so we still have our limit. So if we clean this up a little bit, we'll have our limit as x approaches 5 of x minus 5 over x minus 5 times the square root of x minus 3 plus the square root of 2. And then from here we see that we have a common factor in the numerator and denominator of x minus 5. So this can be rewritten, okay, as our limit as x approaches 5. Okay, should have been approaches there. As x approaches 5 of 1 over the square root of x minus 3 plus the square root of 2. Now we can do direct substitution. We can go back to that. So we have 1 over the square root of 2 plus square root of 2. Or we can say it's 1 over 2 square root of 2. And that could be our answer. Or if you need to rationalize this using some properties of algebra, you could multiply this by square root of 2 over square root of 2. So another format you could have it in is square root of 2 over 4, which means the same thing.